Hello everyone, my name is Avkash, and in this video tutorial we are going to experiment with Pandas and Plotly to build the multi-layer geo maps. We are going to combine the various types of maps such as scatter map, density map, hex map all together into one single map to represent the same data in much more beautiful and much more informative ways. For example, here you are seeing a map of various Walmart locations in all over United States. However, this information is missing that where these stores are in those individual states. So by combining the multiple layers of scattered plot along with density map, this map can be transformed into this map. Here, the same information is represented in multiple layers and each layer represents each state. In this another map where we are combining three different layers of information, we have all the Walmart locations exist in all over United States in this hex map. Then we have certain states such as Washington, California, and Texas represent the density map of all the stores in those individual states, and we also have the scattered plot showing all the locations for Walmart stores in New York. So this map is a combination of three different kinds of mapping layers stacked each other to represent your Walmart store's location. In this example, we have the total number of Walmart stores in each state, but this information is limited and not much more informative, and it can be transformed into this map, where you have the Choropleth map showing not only the total number of stores in each individual state, but also where these states actually exist. In another example, here we are combining the Choropleth along with a scattered map, where you are not only seeing the total number of stores available in United States map, but also you are seeing the individual state-wise maps density within the Texas state as well as in the New York state. So in this tutorial, you are going to see how you can use the Pandas and Plotly to create multiple different mapping layers and combine them together to build the beautiful and informative maps users. So let's get ourselves started now. So this Jupyter notebook is running from Google Colab. And for this tutorial, we are using the Walmart locations dataset, which you can get it by logging into data.world website. Once you downloaded this dataset locally on your machine, you can visit to your Google Colab content folder and select upload, and that's where you could upload this dataset from your local file system to the Google Colab environment, only if you are using the Google Colab for this tutorial. For this tutorial, we just need Pandas and Plotly Express. I'm reading this dataset, and this is our dataset. This dataset is about 4,654 locations for the Walmart stores in 22 columns. So out of these columns, our interest are in these columns: name, street address, city, state, zip code, country, latitude and longitude. So we have created a subset of our data frame. This data set, which was the Walmart stores list, we have loaded, and now it's a data frame in memory. And this data frame is what a subset of our original data set, which we are interested at this point. Now we need to find that in every state how many Walmart stores are. And for that, we need to use the group by operation. So I will be walking through a group by. So here on this Walmart data frame, we are performing this group by operation by state, and the result will be the data frame group by. So one option is that we take this and we process this group by data frame, or we could do the inline operation on this. So because we want to have the total number of locations per state, so our options are size or count. So let me give you the count first. So if you do the count, you will see that count is definitely came for each store. However, the count is applied on every available column. It doesn't look correct. Let's use the size function on group by. Now size is much better because we have got the every state name sorted plus the total number of Walmart stores in each state. That is exactly what we want. But this result does not look like as a data frame. It means that we need to create this as data frame. So one option is that you take this result and then you convert to a data frame, or you could do the inline operation on that. So you could convert this result set to a frame. So you could say dot to frame. So this result became the data frame. So we have a state name and we have the total number of count per state. So you need to change this column name, which is the 0 right now, to a much more informative. So we could say the name is equals to total. Now this is a total. However, it's not really fit properly. For that reason, you are going to reset this index. So once the index is reset, now the state is there, total is there, and index is also there. So now what happens is that this is your data frame, because if you take this thing and you can perform various operations on it. For example, this is our state and this data frame is sorted on state. If you would want to sort on total, you could say, and you will say that you would want to sort this thing on total. Now values are sorted on total, the lowest number of stores wherever they are, all the way to the highest. So that is what we are performing here. So our result is available, the stores by state. So state and their total, which we will be using next to create the bar graph. So we are taking this stores by state, sorting on total, which we have done, and then this df local is used where x column is a state, y column is the total, and we are creating the bar graph. If we would want to create the horizontal bar graph, then we need to replace this y will be the state and x will be the total, and then the orientation will be the horizontal, and that's where your bar graph is. Now if we perform the group by operation on multiple columns, so initially we use state, now we are performing the multiple columns. And one quick note I want you to check is that when you are using single state, you are passing just one state. You could actually pass an array too. However, if you are adding multiple columns in the group by, you have to pass an array and then size. In our store, we are getting all stores data frame, which is based on longitude, latitude, and state. And the total number of rows are almost 4653. And reason is that because our longitude and latitude is a 6 decimal digit precision, it means it's about 1 meter range. And these Walmart stores, there cannot be multiple on same 1 meter. For that reason, the total is almost 1, almost everywhere. At this point, we have two data frames. One, all the store count, so we name that data frame stores by state, and second data frame is all stores where we have longitude and latitude. So based on these two, we are going to create our visualization. For our visualization, we need the Plotly Express and Plotly Figure Factory effect. The Plotly is using underneath the MapBox library to render the maps. So, and in order to use MapBox with Plotly, we need the MapBox token. This After that, we are building the density. Density map is basically, it try to drop a point in the map depending on your longitude and latitude. And as you zoom out, you are watching from very top. If the points are combining closer each other, they generate the higher density and then color value change. So we are creating a density map based on longitude and latitude. And so for every store location available for us, we are creating a density map. What if we want to represent this density map based on states? Why this the whole area is really very yellow? Because the points are really very close. If we go more zoom in, that's why you are going to see the individual stores. That information is really very good, but it's not that much informative where we could actually identify the stores density depending on state. So we have to change this map based on state, and that's where our next objective is. So one option is that we are taking all this store data and we are creating multiple data frames based on state value. So here we are creating the Washington store, 67 stores, California stores, 281, New York stores, 98 stores, and Texas stores, about 508 stores. So there are 4 different data frames we have created for each store, and now we are creating the density map box for these stores. So what I'm just showing you first, that I'm using the New York store and I'm creating the density map. And here you could see that these are the New York map. If you would want to change this to CA map, and that's where your California stores are visible. So now if you would want to add all these together, the 4 different maps, so the best option is that we are creating a density map, and then after that we are keep adding density map box. So just I took Washington store with green color, and then I added the density map for New York, density map for California, density map for Texas, and just updated the map layout. And this is how we have created our Washington, California, Texas, and the New York stores. And I have created this method. What it does, it adds one density map box as base, and then after it keep adding the density map box on top of it. Just a multiple layers we are creating, and for each layer we are creating the random color also. So random RGB color is created, and that's what it really does. And in order to create the loop, I have just filtered all these stores by state. Let's run it. Oh, I have to run this random first. Let's run it. And as you could see here, depending on individual state, the color combinations are random. But if you would want, you can actually create an array and you can get a better color combination. And this representation shows that depending on which particular state, what is the density of these stores, which is far better visualization than this one, because this one is not that much informative here. So information, what you are seeing here, is way more informative to the user when we are looking into here. Now we can see same problem little differently. Everything is a density map. There are few other ways you could create maps too. And what we are doing next is that we are creating the hexbin map first based on all stores, and then wherever we are interested, we can focus on certain areas. So let me show you this way. So here we are creating the hexbin map using all these stores, and that's what you are seeing here. That tells you where the most of these locations are. Now we are focusing on certain areas. So for example, I'm interested in all these stores in California. So these are the California stores. We are adding in the same map. So that's why now you are seeing the information is 2 different ways. You are creating the hex map for all the locations, but you are also seeing all the locations available in California. Now we can actually add our other locations. So Washington, Texas. Now you could see that we have Washington, we have California, and we have Texas. So we have two layers. What if we can add a scatter map top of it, and then we can show the New York locations? So rather than using the same density map, we are not using the density map, we are using the scatter map and showing all the New York locations. So here you are seeing the three different layers. First, we have the hex map for all these stores. Then we also have the scattered map, which are available for the New York. And then we have the density map for the California, Washington, and the Texas. This example should be clear to you now that how we have added three different types of maps on one single layout. Next comes the Choropleth. So Choropleth map are for the maps where you could actually show the geographical boundary for a given region. So if we create the Choropleth for the United States, all states, you will get each state information. So we are using the stores by state and using the color based on total number of stores in each state. We are creating this Choropleth map. The highest number of stores are in this area. Lowest numbers of stores are the locations, which are something like that. Depending on color chart, you are getting where the total number of stores are. And this information is far more better informative than your bar graph. However, one thing you could do is that you could add the labels. So people will already know, just looking into that where these stores are available in which state. So in this map, we have just added the scattered geo, and we have shown that we need to show the text stores by state. So the state name is also visible. So this map is very good, very informative, but I am interested to know that in the Texas or in the California, where the actual locations are everything is here or everything is here, or are they scattered uniformly? So we have to combine the Choropleth top of the scattered map, and let's try to do that is next. So in the next map, what we are doing is that we are creating the scattered geo for all the New York stores and all the Texas stores. Let me disable this Choropleth first. Let me build this map. So you have seen that here are all the locations available for the Texas stores, for the New York stores. But you would want to show this information along with Choropleth. Let's add the Choropleth where all these stores by states, and then we are adding this. In this map, we could see very clearly that in the Texas, where the most stores are density versus in some area where we do not have Walmart stores. Similar to that, we can also see in the New York area where the most of these stores are. So this is a combination of Choropleth plus Scatterplot to show some of the same information what we have seen earlier, but this information is more informative. Here you are getting a projection based on Earth. If you do not want to have this projection built into, you could change this value, manual Earth, you can disable it, so there will be no projection built into. Now your map is pretty much straight. So before we go, let's move this Jupyter notebook from Google Colab to public GitHub repo. So this Jupyter notebook is going to be available in this Python projects repo, Plotly Multilayers folder. And here the Jupyter notebook is available in this Plotly Multilayers folder. So that's all I have for you in this tutorial. I hope you have enjoyed it. If you haven't subscribed my channel, please do so. I do appreciate for that. Thanks for your time. and I will be looking forward to seeing you in my next video. Until then, thanks so much.